Thank you. This is a 2 p.m. session at the plenary. Welcome to Data Analytics and Visualization. It's 3 speakers during the next hours. I will be introducing myself and then the next 2 speakers, and we will have a 10-minute Q&A session, okay? So I'll start with introducing myself. I'm Diego Montecino La Torre. I'm a vet for training, and I'm a master's in epidemiology and PhD in epidemiology from the University of California, and I've been working with WCS for the past 3 years in the health program specifically, and I've been supporting the data management, information system, data collection, analysis, and so on. During this time period, I have the pleasure and luck to work with around 7 countries, and basically what I'm going to show you is a collection of functions that I wrote in the software called SMART that helped me on my in my daily tasks. And at some point, I decided to put them together as a package, and I hope that some of them are useful for you. So, don't be shy, and the first big question is, please raise your hand if you are not aware what R is. All right, that's surprising. Thank you, Len, for the personality. Who else doesn't? Who is not aware of what R is? Please raise your hand. Okay, Len, I saw you, so you deserve a background introduction. Okay, so basically R is an open source statistical software programming language that was basically built by these 2 guys from New Zealand, Rosie Kaha, Robert Gentleman, from the University of Auckland. If you want to learn more about it, they have this huge project, and basically this is the website where you can download the software. The most interesting thing, as I said, is that it's open source, but this is what supports R, is that it has become very popular, and basically this is the distribution of daily downloads times in every single month. And basically we're talking about 5 million times around per month, and then the packages are even higher. There is about 6 million download packages per day. And I said the download times per day wrongly. It's about 500,000. Okay? And basically, this is the symbol of the package. This is my 8-year-old nephew's symbol. It's definitely a work in progress. This is what, I don't even know what he has this line here anyways, but I told them that I was going to show it up here. And the first function that I want to show you is, okay, the first thing is, what the package does is basically goes into Connect using your password, using your username, and then brings back information. But to get output from queries, the query must be already set up in Smart and then uploaded into Smart Connect. So basically, that's what the title is, closer but not connected, because it doesn't get into the system of Connect itself. So with this library, whoops, here we go. So I'm opening the library to install it from the website where the repository is for the package. Then I'm loading the library, and then what I'm going to get here is, this is the only one that I'm going to run live, okay, for the sake of time. Okay, so with the very first function, what I'm doing is going into the server, putting my username, putting my password, and then I'm asking, okay, so give me the name of the conservation area that I'm interested in, and give me all the data points. From the query, all data points. But this is because I skipped 1 step, sorry. So this is where I'm going to get the query information, and this function, what it does is it returns all the queries available for the conservation area, plus its information regarding what type of query it is, and if it has spatial information. This is important because it's gonna provide us parameters for the function that actually pulls the information from Connect into the R session. Come on. live demonstrations. Okay, doesn't matter because I run the function before. So if you see this, basically it's a list, and the list provides as an output, each element of the list object is a query and it's information. So it tells me what is the folder in Connect that the query is living, what is the name of the query, what is the type key, and this is a patrol summary basically, and the identifier within the system, and I ask him if it's a special query, and this one says false. And basically, if I ask for SHP or GeoJson output, this is not going to work because the query itself doesn't have special information. But other ones do. For example, this one says it's a special query, and the output is true for this one. So I could actually ask for special information or in GeoJson or HAP. So that's what I did in the previous run, that basically I put the parameters, what is the server, my username, my password, what is the conservation area that associated with the query, what is the query name that I want to run in the server, and then what is the output that I would like to get. I put it here as an SHP, and where that information is going to be saved. The date of filter type, the type of filter, in this case waypoint date, you have 3 types, and then if I want to filter by dates of the information that I want to get in the output, I can do this with the start date and an end date. Okay, so if I get the output, then I have a SF object, which is an R format spatial object, and I have the information of the identifier, what is the source, waypoint date, and 146 more variables in this case that we are collecting for this in this data model. So if I want to quickly see where those points are, I can apply this. I can run this function of the library map view, and I can start playing around. This is, of course, a quickly view, and with more work, a little bit more work, I can split them by date, month, whatever you want. So what's the point of the whole thing? Is that why not doing this directly in a SMART? Because I feel more comfortable working with R. I've been working with R for the last 10 years, and I don't feel as comfortable with queries and that kind of, or running reports, or working or constructing reports in a SMART. Besides, now that if I ever get all the data in one single chunk, meaning points, tracks, observations and incidents in one single object, then I have liberty to run everything or make any kind of summary that I want beyond the options that actually SMART gives me when I'm doing queries. So for example, yesterday I heard someone that said, I would like to know what is the distance that a specific member of a patrol has completed in a specific trail. And I have seen similar questions in the forum as well. So I'm going to do that exactly same exercise. This is an apply exercise where basically I'm going to take all the points from a data model, from a conservation area. That means, again, that my query for all the points is already living in Connect, and it was already built in my Smart Desktop and uploaded into the server. The same idea with the tracks. So basically, this is a patrol type of query. The same thing with distance, again, patrol type query. And finally, the patrol members, okay? And at the end, I have to make a little fix of how the output of the patrol members is provided, because it's in a long format and I want to make it a wide format so I can join them by patrol ID. So if I run the whole thing, and then I can create another function that is not in the package because this is very dependent on how your data looks like in the query. I can create a single piece of data with all the points, the tracks, the distance, the members that exist for the conservation area. Okay? So this is the function that does it. I'm not going to run it, but basically it's available. And what matters here is the output, right? So using other type of document that exists in R, which is called Quarto documents, I can get output that resembles a report. And you can actually get something like this, right? And this is in Spanish because this is data from WCS Chile, the Paruquinca park that we have at the very bottom of South America. And here I'm making something that I haven't heard of a lot, at least in this conference, which is I am running quality control of the data that the rangers have, that are collecting, sorry. So before doing any sort of modeling, before doing any kind of analysis, what I'm trying to do is how can I make an evaluation, an automatized evaluation of specific parameters of the data that the rangers are collecting. Something very silly, for example. Are there, as an example at least, are there any patrols without incidents? That could be, but it would be weird, at least in the area where I am. Are there any patrols that have no distance? That would be extremely weird, but actually it happened, okay? So for example, I'm making quality control of do all the tracks and points have the same system projection spatially? And in this case, they did, but in the very early days, the answer for this question was no, and I had a list of the points and the distance or the tracks that were different from the most amount of points and tracks. Another one is, do I have IDs that are repeated? They used to be IDs repeated following the structure that we have agreed upon on this conservation area. Are there patrols, for example, that had a distance less than 1 kilometer? And now we don't, but we used to have 3. And then this allows us to detect where were the problematic patrols, and we went to the notebooks and correct the information that was there. Then patrols or no incidents, same idea, but we actually also correct them. And then what patrols we did not have spatial information. So this is the first kind of evaluation, quality, okay? And from there, I can go to basically whatever I want. But one of the other examples of application is, this is not the one. Here we go. This is the one. For example, now I can learn what type, and I can ask what is the distance, the patrol distance accumulated by trail and by transport, and the distribution of the patrols per month, per roll, per trail, and then we can do we can go as far as we want. Accumulated distance traveled per month, per transport, and then go into any sort of measurement that we're gonna get. So for example, in this case, I have the list of the rangers and how much they have patrol, or even in a truck or on foot. So this could help to make things even across rangers, like you are not patrolling enough or you are patrolling too much, and try to make things fair, even more fair for everyone. Yeah. At the end, you can actually get something, you can actually get all these outputs in a specific HTML file that has all the sections right here. And I'm gonna show you a very extreme example. This is a different type of data. This is not from a SMART, but basically this is a huge little piece of a script where we start to find different errors in different places of our information. And at the end, I come to get a summary per country with event code, with observation code, and then what is the actual problem. So our data managers can go back and check what is the problem and correct them. Let me see if I have something else. And when you get into R, there's also other things that you can actually solve. For example, as I mentioned, you can make a full book, and I have the example here, actually. Okay. This is what I was mentioning before. You can have all the sections of your reports in a specific unique website, or HTML file, and you can access the different part just making clicks. Of course, this can be shared like this to the rangers, and we, as one of the speakers mentioned it before, we can actually engage them and provide them, cheer them for continuing using, collecting data and see what we are doing, and even they can actually also view what are the trends in the protected area. You can make different languages for this as well if you want. And finally, the other thing that R comes to solve, well, there is no ending for options in terms of plotting, but you can actually create dashboards on your own, completely free. And these dashboards, as well as these documents, the one that I'm showing you right now on the screen, they can be set up so they get automatized and they run again on a periodic basis. So we can set up, let's say, I want this script to be run every week, every Sunday afternoon, so the people on Monday early morning, they have the new data that has been collected over the past week, and the websites and the dashboards are updated automatically. This is something that was built in R as well. And finally, the last tip is, because I'm over time, the last tip is what happens when you have big data and basically there's no place that you can manage this. I have heard this case in a specific country where they have already so much data that they cannot run it on a regular computer, and if they run it in Connect, they cannot get the output on the computer because it just consumes all the memory. So with R, you can actually access to resources like Spark, which is kind of the state-of-the-art way to handle big data in terms of running scripts, but also to load them in your own current session. And basically that makes things easier and you can see them. If you have further questions, please let me know after the session. All the functions are freely available on the website that I posted on the channel of the application of the conference. And next, I'm going to introduce Andy Wallace, who recently talked. I'm going to say that Andy is an IT project director and innovation manager at Athos with over 35 years of experience, delivering large and complex IT solutions in Europe, Asia, and the Caribbean. Following a recent sabbatical to study for master's degree in marine and coastal environment management, he now specializes in digital solutions for sustainability and biodiversity. Current interests include remote sensing, Earth observation, artificial intelligence, and machine learning for biodiversity and wildlife conservation. Andy.
Hello again. I think many of you were in the room an hour ago when I spoke, and I'll cover some of the same ground again because a few people will be in a different place. But what I want to do here is zoom right out to a much less detailed view and just provide a little bit of an overview of some of the areas in which our organization, Atos and WWF, are working together in a way that hopefully can build connections and spark ideas to follow up in the future. So I've already stood on this stage and talked about one of my projects, but it fits into a program of work that we've set about doing. On the top left-hand side, some of my colleagues have been working with WWF to really begin to start asking questions industry by industry about how we can try and reduce the carbon footprint of industries. I'm going to talk a little bit about our Axis 2 projects. Axis 3, we are seeking to engage all our own staff who are not conservationists, they're technologists, but trying to get them access to wildlife conservation organizations so they can spend a bit more of their time volunteering. And we're a French company, and so we've done some additional work with WWF France that I shall not be talking about. So my area is this Access 2. I've already talked a little bit about project number 1, which is our key biodiversity areas monitoring. I will not be talking about my second project, which is working with the WWF Counter-Illegal Wildlife Trade Hub in Hong Kong to try and work together to look at demographic and geographic factors behind zoonotic disease prediction, actually how I first met Diego. And I will touch on project 3, which is some work that my colleague Trinesh Idimukwala, who some of you know, some of the SMART team will know, who unfortunately couldn't be with us here in Namibia this week. So I'm going to talk a little bit about his project, and because it's his project, I won't be doing much detail. And hopefully that will give Ruari enough time to talk in more detail about his project. So we were asked if we could help as software developers and technical people to think initially about, how does SMART get deployed in the first place, the first time it gets used in a new environment? We talked to different parts of WWF, and I'm not going to do much detail on this because I see people in the audience who have already spoken about it, and I've already got some stuff in this slide pack which I know from a conversation at breakfast is incorrect, so I'll go very rapidly over that. But the second 2 points are our direction of travel, things we would like to do in the future. So again, I'm going to try not to talk too long. My intent here is to just provide a high-level flavor, a very zoomed-out flavor of some of the work that we're doing. And the first thing that we do, so one thing which we've done and two things which we would like to do and hope to start soon. This is the one that we have done. There are people in this conference with us today who know far more about the detail than me, so if we want to follow up, I will be pointing you at somebody else. But what we have been trying to think about is when a conservation manager somewhere or a group want to do that first install, there's a series of events that we go through. Understanding where to find the software in the first place, this technology Docker, which is containerizes, puts wrappers around technical stuff like code, which can then get built onto an environment. Then we need to set up a database and data models, and then we can get cracking on. And it's taken us many months to do, and I've just tried to show it in one simple picture here. What we're starting to do is write scripts to try and hide some of that complexity, because we're aware that there are many people out there who know this stuff really, really well and could do it without even breaking a sweat. Other people who come at it first time, sometimes in remote locations, sometimes without necessarily having technical support on hand. So that's what we've set out to do, is try to make it easier for people doing that initial install to have a nice script where you press install and it does all of the work. We haven't yet tested it, to the best of my knowledge. We need to go through that process. And if anybody has any questions, we can make connections afterwards. I'll touch very briefly on two other things. We have not yet done them, but we would like to do them. And through the people we meet in this room today and yesterday and tomorrow, we'll learn more about how to do that stuff. The first is around human-wildlife conflict. So we're aware of many things that WWF and other organizations have done. There's a phrase which I've just about got in the title somewhere, conflict to coexistence, where there are policies in place where we can ask questions about whether there are policies in place at government level, at local level, on the ground, in order to protect people from animals, protect animals from people, and as somebody said yesterday, protect people from people as well. So as I said, we've carried out some analysis. We've begun to look at the tools which are used now and beginning to think in the context of analysis and SMART, how might we begin then to define tools in the SMART system which can gather the data, which can then feed some of the stats around this. So we're looking at things we've done for other purposes to see if we can reuse it, try and come up with some standard patterns for creating templates, bring those into SMART, and then create a much more intuitive way of capturing the data so that we can get nicer tools to deliver. Again, statement of travel, that's a future plan, something we would like to continue to do with WWF in the future. And the other thing we really want to do is engage our people. We work for, there's approximately 100,000 people in the wider Atos organization. We initially want to start with our colleagues in India, who've got a great deal of experience in building IT systems. We want to harness some of that creativity. We've not done it yet. There's a few promises outstanding from me that I've now stood on a stage and made, so I'm going to need to follow up on, about trying to help our people to know a little bit more about what SMART does, so that we can then begin to capture some of that creativity, and we'll have some people with some really crazy ideas, some people with some really good ideas. We'll put it into a pot, mix it up, and that's what we would like to do. How can we use this sort of IT technique that some of you will have heard, the hackathon, bringing a bunch of people into a room for a 24-hour period, for example, usually a virtual room these days, not a physical one, in order to try and throw ideas around, come up with some stupid stuff, some good stuff, and hopefully get some good ideas which we can lead into in the future to try and come up with better ways of visualizing data. So again, not much of substance that we've done other than the build at this point, but just wanted to say this is what we would like to do as an organization in supporting SMART, in coming up with easier, simpler, more streamlined ways to use the system in the future. And at that point, I shall stop and hand back to Ruari.
Okay, so Ruari is the Chief Technology Officer at Langland Conservation, working there since charity was founded in 2021. In this role, he develops the organization's capability to deliver intelligence insights to the conservation sector through managing Langland's data and technology projects. He has worked on a range of intelligence capacity building projects, including with partners in CIR and the DRC, to equip national parks with robust tools to manage and analyze their data. He specializes in GIS, data management, data visualization, intelligence investigation, and computer vision. Prior to working in conservation, Ruari worked for 5 years in the public sector and studied at the King's College London. Welcome.
Thank you, Diego. I'm going to go deep into one individual project that we worked on where we learned a lot of lessons about data visualization, and I'm hoping to share some of those with you. So Langland Conservation was founded in response to several urgent requests from various projects across Africa for additional capacity, analytical capacity. And we've typically worked in support of organizations that find themselves in very challenging environments. And that could be for a range of reasons, either due to the risk of conflict, their remoteness, or the scale of the pressures that they're facing. And we now support over 20 projects in 16 different countries and are proud to have links with a range of different partners, as well as be supported by a range of technology partners that let us give capabilities to those that need it most. And just a few of those partners you can see there. And we do three key things in our work. We provide analytical support to decision-making, ranging from local projects with highly specific information requirements to wide-ranging operational analyses in support of protected area management. We also aim to provide support to organizations that help law enforcement using our capabilities to disrupt international wildlife trafficking beyond the extent of park boundaries and across national lines. And finally, and what I'm going to talk to you a little bit about today, is our effort to transfer some of these capabilities to projects to build long-term, sustainable local capabilities to continue the provision of high-quality analysis long after we move on to other projects. And that is Zangabai in Zanga-Sanga National Park. For background, that's nestled in the southwestern corner of CAR, bordering Cameroon and the Republic of Congo, as part of the Sanga trinational landscape. It's an extraordinary tropical rainforest preserve and a critical sanctuary for forest elephant, for gorilla, for chimpanzees, amongst many other species. And it's also home to the indigenous Bayaka people who play a critical role in the landscape safekeeping. So SMART existed long before Langland came on the scene at Zanga-Sanga National Park, but we were asked to assist with the park in how they could get more value out of the tool and how it could better drive decision-making. So over the course of several site visits and in close collaboration with WWF, Chengeta Wildlife, and the park staff, we sought to shift the focus past effective data collection and management and towards effective data exploitation to support decision-making. The first step very much was to make sure that high-quality data was coming back from the field, so we worked closely with the team to redesign their data model to better reflect their information requirements. And we also worked really closely with very fresh EcoGuard recruits to identify areas where we could basically take advantage of as many opportunities to streamline the end user experience, to make it as intuitive as possible, to mitigate against the risk of data inconsistencies, and make them enjoy using the product and feel very much part of the data collection effort. We also cut back a extremely long and table-heavy report to put a much clearer focus on the most relevant data for decision makers to get as much value out of the data that was hidden within those pages previously. This has then naturally progressed to looking at how we could transition from information and into intelligence. And I'll just spend a minute giving you my take on what that means. So information is your raw data coming in from the field. A single observation at a single place and time doesn't necessarily mean much on its own. It doesn't hold much value until you take advantage of the potential in that building block to place it in a much better and much more informative picture. Sadly, if we just keep chucking those building blocks in a box, we're going to end up with a slightly jumbled mess, and it's going to become very difficult to retrieve that information and assemble it in a constructive and valuable way. And that's where SMART comes in. That's not my bedroom, but that's my idea of what SMART does for my building blocks. And it lets me meticulously organize those building blocks in a way that I feel good when I assemble those into an intelligence picture. It makes it easy, and it lets me spend more time being creative and adding value than trying to find the bits and bobs that I need. Intelligence is where you add value by putting those building blocks in the context of what is it that I can do about the situation? How can I interact with my environment? And how can I do my job better? Understanding threats, understanding opportunities, understanding trends, and understanding correlations. Measuring success as well, and identifying information gaps and activity gaps, and also facilitating the effective transfer of information as part of a cyclical process to continually improve and passing information sideways, passing information upwards, and passing information back out to the field. SMART does come with a range of tools to begin analyzing this information, and that's where I'd suggest everybody starts with trying to transition from raw data and into intelligence. Analysis is a fundamentally creative process, and there shouldn't be anything that stops you following the instructions, building that first model, and then beginning to bring in other things into play. So not only do you need to interact with SMART data, but you can also bring other analysis into that as well. For example, you might have open source data sets of where the population is. You might have information you can infer from spatial monitoring, remote sensing, your collar data, which may be held in EarthRanger. And an environment that lets you place all of that together is something that's incredibly valuable for driving decision making. What we wanted to do is put all of that information, everything held within SMART, and everything that one might like to add to that as well, and put that at the fingertips of the analyst in a way that they could rapidly test hypotheses and interact with their data. And all of that was just a click away with all the friction of data compatibility removed out of the picture. And that is a year of SMART data put at the fingertips of the analyst in Zanga-Sanga. Everything just there, one filter away, and can be visualized in a range of different methods. So, for example, you want to reduce those frictions for him interacting with the data. You want him to be able to ask the questions, if I take these data blocks that represent my patrol effort and these blocks that represent my wildlife observations, not only do I know where I am and where the wildlife is, but I can also then begin to correct for my information biases and spot potential gaps in my organization's situational awareness. Another example, if I take these blocks of criminal activity and these blocks of where human habitation is, I can understand where my community engagement efforts need to be and where they'd likely have the greatest effect. If I also understand the routes coming out of those areas and where criminal activity might be happening, I know where I need to intensify my patrol activity. So to empower the analysts to ask these questions, you need to give them an environment where they can rapidly test and visualize their thoughts. And that's what we did in Zanga-Sanga. So much of our work revolves around these little hexagons, and here they are being dynamically generated through time as that time filter moves on, showing a particular type of observation. That should animate but it's not going to there. The reason why we like hexagons is that's a quantified amount of data in a particular pot. A heat map is going to give you a relative impression of where activity is happening compared to where it might not. But that doesn't give you much statistical ability to infer across different data sets. This gives you a really clear-cut ability to inform the basis for things like efficacy studies, where you are essentially taking patrol effort and you are accounting for the fact that you may have an information bias within the way that you're collecting information. Efficacy studies, understanding factors like correlation, for example. These little hexagons really support that kind of line of thinking. And it's not just hexagons and that we provided, but we also look to make sure that graphs, for example, could be visualized over time so that we could spot trends. And this is all of the SMART data held within this dashboard, and you can simply apply individual filters and animate that through time to produce hexagons that are dynamically generated, as well as heat maps. And that also acts as a basis to bring in other data as well. Satellite imagery, for example, you could use the Microsoft AI buildings data set to understand where human habitation is. And on the right there, you can see that we've provided an environment to bring in elephant collar data, which in this individual park was being stored in EarthRanger and then extracted via a software called Ecoscope, which you may have heard of earlier. And one of the key things is to spend as much time in that zone playing with the data and as little time dealing with something that I would call friction. And friction is that unseen force of incompatibility issues, little niggly things, manual processes that you need to do, translation issues, the things that essentially eat up our time and resource and that we face every day in our work. So our first priority in introducing this process was to make it not something that would be dropped instantly because it seemed insurmountable, but something that could be done in a single click of a button to bring in all of that data. Because we were working in a francophone environment, and there are little issues with exporting data from smart, particularly dates, on a French OS, there was quite a long data cleaning process that we had to go through, which would have taken the local analyst potentially upwards of an hour. So what you're looking at there is ArcGIS's internal model builder, where in a no-code environment, you can just chain geographic processes together and wrap those all in a single button. What that does is give you the ability to do a 2-week project in a park and then hand over an incredibly easy process that can be repeated as part of daily business. And the other important thing is creating a positive feedback loop. The data and the visualization is all well and good in and of itself, but it's really important to feed that into routine processes that extend simply beyond looking at a computer screen. What you're looking at there is the process that we've put in place to essentially the patrol commander will handrail an automatically generated map with the icons of their encounters and a log, and he will talk back to the local analyst and to his superior what he's seen, what he thought it meant, the rationale between the decisions it makes, and that's really important for that up and down transfer of information and knowledge. And what it also lets the analyst do is assimilate information from the ground that isn't just represented by dots and hexagons on a map. It lets them ask questions of what that means. It lets the transfer of like photos of camps and really builds up that analyst's capability to better interpret what he's seeing through the lens of data by having that additional context. And finally, it helps put our activity, conservation activity, in the context of the environment. And I think data visualization is very important for that. And SMART is incredible for looking at our activity, what we're doing out on the ground, the places we've been, the things that we've seen. But these factors that sit around our activity, they interact with each other, and wildlife observation data isn't the only lens for looking at that. We can bring in understanding about the physical terrain. We can integrate aerial surveys. We can understand where the population is through open source data sets. We can confer with law enforcement. And I feel it's very beneficial to have a hub where all of that can be brought together. So that's what we did in Zangasanga, and it's been my great pleasure to tell you about it. Thank you very much. Sure.
Can we get a microphone for questions and another one for us? Okay. Any questions? Sir. The microphone is coming.
Thank you for the nice presentations. And my question points towards the smarter scenario. Just as you expressed there, the smarter program combines R software with smart. R by itself has more than 1,000 plugins. How will be smart combined with it? As a plugins, or will it be together? Will you use them both together? This is my question. Thank you. Do you get me?
I'm sorry, could I just trouble
No, no, smarter program for you, my question.
Could you repeat the questions? Because I'm not an English speaker, so... okay.
Just you show that R will be, smart will be combined with R, and they will be smarter. R by itself has many plugins.
Yes.
Will smart will be we will use as plugins or stand by itself?
Yeah, thank you. Yes, I got the question. So some of you might know that there is an R plugin in a Smart, right? Already. So that plugin of R in a Smart has nothing to do with the Smarter. Why? Because the plugin of R is an IDE, meaning I can run functions and I can run R scripts directly in a Smart. What it does, it calls parameters from the queries and run a Smart in the backend, okay? This, you can actually, Smarter, you can use it by itself. You just need R, and what I was showing, what I was using specifically is R Studio, which is just another software to make things easier for working on it. But everything is for free, and what you do need, for now at least, is a server, a Connect server, from which you are calling, you are telling, through R, you are telling to Connect, run this query, and bring me the output and show it in my screen. Is that good? Okay, cool.
Thank you. Thank you for the great presentation.
Give me 1 second, Lena.
Yeah.
Sir, please.
Hi.
Sorry.
I had a question for the gentleman from Atos there. What is the relationship between your effort and I saw a very interesting presentation about Ecoscope. And I understand, Docker containers within Airflow and all that. Is there a relationship between what your effort is and Ecoscope, or?
So there needs to be. I was not aware of EcoScore until this morning. I was particularly pleased to hear that they were developing on the Google Cloud Platform, because so are we. I heard people say some technical terms, which I won't repeat right now, but those technical architects appear to be speaking the same language as some of ours. And it has made me feel, having witnessed that conversation this morning, that some of the things I would like to do, I might not need to do, because some of those integrations might be built in Ecoscope already. And in particular, the Gundi engine, I'm wondering whether we need to drop some of our plans for building user interface and simply provide the data via Gundi into existing user interfaces which other people have already built. So I feel that my presentation was a little light on content, but hell, I've learned a lot, and that has some value. Quite.
Yes. Lena?
Thank you, Diego. So it is related with the previous question. So as far as I understand, you don't need Connect to use R. You can use R plugin then from desktop. That's the first question. And also, if there is a user manual, because there is one, but it's very general. I don't know if it is in the plans for the Smart partnership or so to have like a more specific case where you can actually, for instance, run what you just did, and step by step, I understand how to do it from SMART?
Yeah. So again, there are two things, and I want to make this clear so we avoid confusion. There is one R plugin already in a Smart Desktop, and there is the package that I just presented. Okay. So in the case of the R plugin, you do need queries. You don't need connect for the R plugin that is already in desktop. And what the plugin needs is a query that provides the parameters that goes into a script that Smart Desktop can run by itself using R in the backend. So you don't see the program, but it's actually doing that. My understanding is that there is a video of a training of an example how to use the R plugin. And it was done by Gray Russell. He works in a conservation NGO in Vietnam. He rediscovered how the R plugin worked because he wanted to use it, but he didn't find any sort of documentation how it works, and it was a mystery, and he kind of put it back again on track. In the case of the package, you don't need a Smart Desktop, but you do need a Smart Connect, and the query is already in place in a Smart Connect.
My question is directed to, is it Ruari or Ruari?
Yep.
Okay. If I followed you correctly, you mentioned that you use hexagonal bins to quantify data because it overcomes biasness. I find that quite interesting. Is that the case? And if so, could you explain that a little bit more in depth?
So using the hexagonal bins in and of themselves does nothing to correct bias. It simply lets you have a single format of representing data that any amount of point data can be compared and contrasted in different ways. So you have one data set for patrol effort, one data set for wildlife observations. Both of those are represented as a number in the same space. And therefore, you can do a mathematical calculation of, if I divide my patrol effort by the number of things I've seen, vice versa, I'm going to get some measure of the interaction between those two. And therefore, I can see where the areas are that I'm patrolling lots and not seeing very much, the areas that I might patrol only a little bit, but I've seen quite a lot and therefore are likely very valuable, and also the areas where I know absolutely nothing about at all, which means I probably need to send a patrol down there at some point to fill a gap in my situational awareness. Does that answer your question?
Yeah, to some extent. So the shape of the bin doesn't really matter. It could be a square as well.
You could use a cell grid, and the cell grid is something that very much most Smart users will be more familiar with because that's the default representation in Smart. We simply prefer hexagons because without getting too much into the maths, in a cell, everything around of it, the ones up, down, left, and right are a different distance to the ones that are diagonally in each direction. Does that make sense?
Yes. All right, thank you.
So no more questions? Okay, thanks. Yes, sir?
Thanks. Yeah, it's interesting to see how people are visualizing data differently than in the Smart package. One of the things in creating Smart that we had tried to do is to make it very easy for people to access their data. How readily, I guess for each of you, how readily can the average Smart user who doesn't know R or can't contract with somebody to build a whole system for them, is it possible to use these approaches that you've demonstrated without having extensive knowledge of the particular platforms in which you've created your dashboards and visualization tools?
Russ is going to give a slightly different answer to that. What we're trying to do is make the assumption that our audience is going to have very, very mixed ability. So we'll try and build some simple visualizations that don't go too far down detail to just provide that flavor and then help people know how to interact with that. So we might find, for example, that we'll take a sort of persona approach. We'll imagine maybe a community organization or a scientific user or somebody maybe who wants to look at a very wide region and then think about those kind of outputs. So for example, a scientific user might not be very interested in our interface, but might want to just press a button and get the raw data out. A community user might want to be able to draw a circle around an area that they know and get real detail in that space, whereas somebody at a maybe more sort of international or policy level or governmental level might want to see trend over time. So we've sort of made the assumption that what we need to do is keep the data in a way that different interfaces could be built to serve those different communities and build a very, very simple user interface. But I imagine you two will have a very different answer.
So my perspective on that is I think regardless of what technological solution you're going to bring into an area, there is always going to be some kind of point where you're heavily invested at the start, whether that's setting up a smart data model, setting up an EarthRanger configuration, and then that's going to be handed over, and you'd hope that it continues working after you draw down your support. The system that we developed there was handed over in no more than 2 weeks, and that was taking someone from now having never seen ArcGIS before, putting that in place and then handing that over to them. And essentially that was toggling on and off layers, operating a time slider, and then using the same kind of query interface that they'd be familiar with within SMART to manipulate the data that way. So I think it would be difficult for a park without external capabilities or without someone with some experience of GIS to set that up. It would be quite a long road and a frustrating road, I imagine, to do that. But it's something we'd very much hope could be handed off and then continue to be operated after we depart. And we'd be more than happy to share our process for doing that as well.
I just would add that although you don't have clicks, and I understand the limitations of writing scripts because it's a new way of writing, basically, that you have to learn, R is very, very simple for the amazing capabilities that it has. And I think at some point, everyone is going to reach a moment where we need to find someone that does this or train someone that does this for us. And that's a process that actually we are trying to accomplish within WCS in the Latin American countries, just to build that capacity of, okay, we have the smart data, we have our rangers, SMART is already implemented, we need something else now to start, as Ruari said, getting intelligence out of it. Yeah, and I think it's totally worthwhile to make the investment just because there are, as I said before, I have assessed data just in its quality, and that's such a basic step that is surprising, the things that need to be reinforced and corrected from the data before getting to these marvels. And I think that the argument is also explained by the success that Ruari's organization has had in 2 years, that there is this need for capacity to support analysis of information for protected areas. Any other question? Three, two, one. All right. Thank you so much for your attention.